Hi, welcome to Precalculus. Topic today is finding solutions in an interval for a trigonometric equation written in factored form. So the equations that we see in this section, they are product of two or more equations we had seen before. So in this first example here, we want to find all the solutions of this equation. The equation itself is tangent of x times 2 sine of x minus radical 2 equal to 0. The main principle we are going to use in all of these problems here is that if you have an item times another item equals to 0, either a is equal to 0 or b is equal to 0. And this property only applies to number 0. It's not that if a times b is equal to 5, we would say either a is 5 or b is equal to 5. No, we don't have such a thing here. It is essential that the right hand side of the equation is 0. Sometimes we refer to this as zero factor theorem. Okay, how do we solve it? Very simple. We just apply this principle. Here is an item, tangent of x. Here's a second item. Either we have tangent of x equal to 0 or 2 sine of x minus radical 2 is equal to 0. Well, we have solved this thing before. X can be 0, pi, 2 pi, etc. In this problem here, we are only looking for problem solutions in the range from 0 to 2 pi, and this one just gives us 0 and pi. This one tells us that sine of x is equal to radical 2 over 2. You can look it up in your table or in your circle. Sine, we said, matches with y-axis. That's the second component. If sine is radical 2 over 2, here's, if the sine is radical 2 over 2, we can be either of these two locations, that is at pi over 4 or 3 pi over 4. So we write these things here as well. That tells us x is equal to pi over 4 or 3 pi over 4. Overall, the solution of the problem, if you want to write them in order, 0 is there, pi over 4 is there, 3 pi over 4 is there, and pi is also there. These are the solutions that are in this interval. If we wanted all the solutions, we will add 2k pi to all of these, and then we'll have all of them, or we could abbreviate that somewhat like what we said in the previous lecture. Okay, here again, remember, this is like a, this is like b. Either we have cotangent of x plus 1 equal to 0, or 3 cosecant of x plus 2 radical 3 is equal to 0. This implies that cotangent of x is equal to minus 1. We said in the previous lecture that this means tangent of x is equal to minus 1. Now, 2 ways or 3 ways of answering this question: looking up in the table, or to get a confidence about our answers and building some intuition ourselves, we said we draw the unit circle. In this case, we also draw the tangent axis. This is the tangent axis. In this tangent axis, we put minus 1. Minus 1 would be here. Connect to the origin and go all the way. These two angles are the ones we want. Since we are limited to between 0 and pi, instead of this negative angle, let me take this long road to go there. So my answers will be x is equal to 3 pi over 4, and this one is pi 4 short of a full rotation, that is 7 pi over 4. For the second one, cosecant of x becomes 2 radical 3 over 3 minus 2 radical 3 over 3. I took this thing to the right hand side, became minus 2 radical 3 divided by 3. That's what we'll get. Cosecant is 1 over sine of x. So 1 over sine of x is minus 2 radical 3 over 3. That tells me that we take the reciprocal of both sides, it becomes 3 over 2 radical 3. And the minus, I can put that minus anywhere. Simplify sine of x. How do I simplify? Multiply by radical 3. Multiply by radical 3. Let me write it down. Minus 2 radical 3 to make it in more familiar form. Rationalize. Multiply by the radical you're trying to get rid of. What do we get? Becomes minus 3 times radical 3. 2 radical times radical, that is 3. 3's cancel. All I got out of this thing is minus radical 3 over 2. Okay, again, how do we get, you can of course again go to your table or circle and get minus radical 3 over 2, minus radical 3 over 2, sorry, you see it here. That's 5 pi third and 4 pi third. That would be the answer. However, to make sure that we have some intuition about this thing other than looking it up on the circle or the table, minus radical 3 over 2. First of all, we remind ourselves vertical is the sine axis. On that sine axis we go and locate minus radical 3 over 2. Draw a line at that location. We connect the intersections to the origin. The angles that we are looking for are these two angles, this one and this one. Between 0 and 2 pi, those are the answers. So x that I get, this smaller angle, this is 60 degrees, a pi third, with the pi gives me 4 pi third. This is again pi third, subtracting it from 2 pi, it gives me 7 pi. Excuse me. So how did I get this one? 2 pi minus pi third. 2 pi is a full rotation minus pi third. When you subtract it, you get 5 pi third. So final answer, we have to list everything we got. We had 3 pi over 4, and then 4 pi third. You don't need to list them in order, you can have it any so the only thing Alex expects from you is to separate them with commas. That will be sufficient. Okay, so here our equation is cosine of x is equal to 0, or cotangent of x minus 1 is equal to 0. So this means x is either pi over 2 or 3 pi over 2. If you want to get a picture out of it, here is my cosine axis. On the cosine axis, I go find the required value, that is 0. Draw a line from there to the origin. Excuse me, draw a perpendicular line at that location. two angles that I'm getting are these two. Second one, it tells me that cotangent of x is equal to 1. Reciprocal of this thing is that tangent of x is equal to 1. Tangent of x is equal to 1. Here was the picture for it. We said we draw the tangent axis. Here's the tangent axis. Find 1 over there. Connect to the origin. These are the two angles that you are looking for. So x will be pi over 4. Pi and pi over 4 is going to be 5 pi over 4. So all in all, we have pi over 2, pi over 4, pi over 2, 5 pi over 4, and 3 pi over 2. It's the final answer for all the possible cases that we have. So what is it that we learned here? If you have an equation that's made out of product of several items equal to 0, then either of those two parentheses can be 0. This is only applicable when the other side is 0. It does not work for other numbers on the other side. So if a times b is 0, either a is 0 or b is 0. And then we just track the two possibilities, collect all the possible roots, collect them in one line, and then that is the solution to the problem. This is for case where we are limiting ourselves to 0 to 2 pi. For other cases, you just add a multiple of 2 pi to them, and then you'll be all done. Okay, so until next time, good luck and God bless.